Hi dear students, today I am starting a new lesson, light reflection and refraction. So in this chapter we will be discussing about several concepts. So in that first one is light reflection and second one is light refraction. So in light reflection we will be discussing about reflection through plane mirror, reflection through spherical mirror and image formation through spherical mirrors, and after that in refraction we will discuss about refraction through glass slab and refraction through spherical lenses. So after completing this we will be starting power of lens. So after this we will go on to the numericals. So first, before starting reflection of light, so let me give you a brief introduction about light. So what is light? You already know about light. What is light? So light is a form of energy that enables us to see the things around us. So you have already know this from the 8th standard. So what is light? So light is a form of energy that enables us to see the things around us. Without light we cannot see any things around us. So you also know that light travels with a speed of 3 into 10 power 8 meter per second. So this all you have learnt in 8th standard. So I will repeat it once again. So light is a form of energy that enables us to see the things around us, and light travels with a speed of 3 into 10 power 8 meter per second. So you also studied like ray of light and beam of light. So a ray of light is nothing but a straight line with an arrow. We call it as ray. So this we call it as ray of light. A straight line with an arrow we call it as ray of light. If there are several such straight lines, then we call it as beam of light, right? So light is a form of energy which enables us to see the things around us. Light travels with a speed of 3 into 10 power 8 meter per second. So if a straight line with an arrow we call it as a ray of light, and there are such several lines we call it as beam of light. So you have already studied like light is a form of energy that enables us to see the things around us. Let us discuss few properties associated with light. So you know light is an electromagnetic wave, so does not require any medium to travel. So like what is electromagnetic wave? Like you have studied in the previous 9th standard, like sound requires some medium to travel, like it needs air or it needs solid, liquid or gas to pass through. So whereas light, it does not require any material medium for its propagation. So for example, you take vacuum. In vacuum there are no particles, so light will travel through vacuum. So that is the reason they are saying light is an electromagnetic wave. So it does not require any medium, whether it is liquid, solid or gas. It doesn't require any medium, it will travel through vacuum. What is vacuum? So vacuum is a free space which will not contain any particles. So light has the ability to travel through the vacuum. That means it does not require any particles or any material medium for its propagation. So that is why they call it as an electromagnetic wave. You also know light tends to travel in a straight line. This you have know. And light has dual nature. Light behaves as a wave as well as a particle. So dual nature of light you will be learning in higher standards. So next is light casts shadow. So you know this also, without light we will not be getting any shadow. So speed of light is maximum in vacuum. So I already said you the speed of light is, that is 3 into 10 power 8 meter per second. So it is maximum. So why he has given as maximum? Because speed of light varies from one medium to another medium. So it is maximum in vacuum, that is it is maximum where there are no particles. So when the same light enters to water, its speed reduces. So when the same light enters to glass, its speed reduces. This we will be discussing in the part of refraction part. So that is refraction through glass slab. Next is when light falls on a surface. So what will happen? So when light falls on a surface, reflection may happen, refraction may happen, absorption also may happen. So depending on the medium where it falls. So if it is a mirror, reflection will take place. If it is a glass, refraction will take place. If it is some other material, so absorption may takes place. Now we will move on to the next concept, reflection. So what is reflection of light? First question is, what is reflection of light? So bouncing back of a light when it strikes on a polished surface like mirror, we call it as reflection of light. Or in other words, we can say bouncing back of a ray of light when it strikes a medium where it cannot pass through, we call it as reflection of light. So reflection of light happens in the case of mirror or any polished surface. Okay, so reflection means bouncing back of a light when it strikes on a polished surface like mirror, or bouncing back of a ray of light when it strikes a medium where it cannot penetrate through or pass through, we call it as reflection. In reflection we will come across some laws. So let us see what are those. So laws of reflection. So in the laws of reflection, first you have to take a plane mirror. So you can see from the figure there is an incident ray and there is an reflected ray, and one ray is normal with a red dot, that is normal to the plane of the mirror. Okay, so incident ray you see, reflected ray you see, and the angle made with respect to normal from the incident ray, that is the angle made by the incident ray with respect to normal, we call it as angle of incidence. Similarly, the angle made by the reflected ray with respect to normal, we call it as angle of reflection. So let us see what are the laws of reflection. So first law is angle of incidence is equal to angle of reflection. From the figure you can easily see, or you can easily say, that the angle of incidence, that is angle made by the normal with respect to incident ray, and the angle of reflection, that is the angle made by the reflected ray with respect to the normal, both angles are same. So that is what the first law says, that is angle of incidence is equal to the angle of reflection. So second statement says that the incident ray, the reflected ray, and the normal at the points of incidence all lie in the same plane. You can see from the figure the incident ray as well as the reflected ray as well as the normal drawn at the same point, same plane. Okay, so second law of reflection states that the incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane. So these are the two laws of reflection. Let me repeat it once again. Reflection is the bouncing back of a ray of light when light strikes a medium it cannot penetrate through or pass through, we call it as reflection. So there are two laws of reflection. One is the angle of incidence is always equal to the angle of reflection, and the second one is the incident ray, reflected ray, and the normal drawn at the point of incidence all lie on the same plane. So these are the two laws of reflection. So let us move on to the next concept, that is image. So what is an image? So you might have heard about object, image. So what is an object first? So object is nothing but something you can touch, see and feel, we call it as an object. Something like you take anything, any material, so where you can touch, you can feel and you can see it, so that kind of material or things we call it as object. So what is an image? So let's see what is an image. Okay, so image, it is a point where at least two light rays actually meet or appear to meet, we call it as image. If the two light rays after reflection, if they meet at one point, that point we call it as image point, or we call it as image. So image is that point where at least two light rays actually meet. Okay, if they actually meet, we call it as real image. If they appear to meet, we call it as virtual image. So let us see what are the differences between real image and virtual image. So real image formed when light rays actually meet. If the light rays are actually meet, we call it as real image. So when they actually meet, after reflection they will meet. Okay, so you will be knowing what kind of images are called as real images, what kind of images are called as virtual images when I start image formation in the case of spherical mirrors. Okay, now just know what is real image and what is virtual image. Okay, so virtual image is formed when two light rays or when light rays appear to meet. Okay, image can be formed. They have mentioned here at least two. So more than two light rays also can meet, okay, at the same point. So there also we can say image is formed. But minimum of two rays are required for the formation of image. Okay, so next difference is image can be obtained on screen, whereas that is real image can be obtained on screen, whereas the virtual image can't be obtained on screen. So real image can be obtained on screen means you might have seen in the cinema screen, like when you go to a theater you will see the picture on the screen. So that kind of image we call it as real image, whereas virtual image cannot be obtained on the screen. For example, like you stand in the front of a mirror, your image will be appearing inside the mirror, not outside the mirror. Such kind of images we call it as virtual image. So that is, if you stand inside the mirror, like if you stand in front of the mirror, your image will not come out of the mirror, it will be inside. Okay, but whereas the real image, like in the screens you can see it on the screens, but this virtual image you cannot see it on the screens. So real image, remember, real image is always inverted, whereas virtual image is always erect. So remember this too, real image is always inverted. Inverted means upside down, like you are standing, like your head is at the top. So inverted means your head will be at the bottom, whereas erect means it is as it is, upside, like upright. So if you are standing, your head is at the top only, whereas inverted, your head will go to the bottom. This is what inverted means. Okay, real image is always inverted, whereas virtual image is always erect. So let me repeat it once again. Image, it is the point where at least two light rays or more than two light rays actually meet or appear to meet. If they actually meet, we call it as real image. If they appear to meet, we call it as virtual image. So real image can be obtained on screen, whereas virtual image can't be obtained on screen. So real image is always inverted and virtual image is always erect. Example for real images: image formed on the cinema screen. As I already told you, image formed on the cinema screen is the example for real image. So now example for virtual image: image formed by the plane mirror or convex mirror. So why he has mentioned convex mirror? Because plane mirror and convex mirror always give you virtual image. You will understand as I explain you the image formation in the case of concave mirror and convex mirror. You will understand why he has mentioned convex mirror for the example, as an example for virtual image. Next we will move on to the image formed by plane mirror. So how the image will form in the case of plane mirror? So what are the characteristics of that image? Okay, so now consider an object. See, you can see from the figure AB is an object, and you can see also the plane mirror. So the right side you can see A dash B dash, that is the image. Okay, so let me take one ray from A. Okay, you can see one ray I have taken from A to the plane mirror, so which makes an angle I, that is angle of incidence. So after hitting the plane mirror, since plane mirror will not allow the light rays to pass through it, it will reflect back with an angle R. So here also the laws of reflection holds good, that is angle of I will be always equal to angle of R. So when you draw this reflected ray backwards, and when you draw this incident ray from A backwards, these two rays will meet behind the mirror, like that is right side of the mirror. You can see that point, the two rays will meet at the point A dash. So draw one perpendicular from B dash to A dash, that is where the image is formed. See here, you can see these dotted lines, we call it as image is appearing to meet, the reflected rays are appearing to meet at one point A dash. So since the rays after reflection won't meet actually, but they will meet when you draw the reflected rays backwards at the point A dash, this kind of image we call it as virtual image. Understood now why what kind of images are called as virtual images? If you draw the reflected ray backwards, they will meet at one point, but they won't meet actually. So these reflected rays drawn backwards, they will meet at one point. So that kind of images we call it as virtual images. So now the distance between the object to the plane mirror, we call it as object distance. The distance between the plane mirror to the image, we call it as image distance. Object distance is represented by u, whereas image distance is represented by v. So from this concept we will characterize the formation of image. So you can see what kind of image is formed in the case of plane mirror. I already told you the reflected rays are appearing to meet at one point. So as the rays are appearing to meet, it is always virtual. While explaining the difference, I said you virtual image is always erect. So erect in the sense upside down. So see, the object is AB, it is erect, whereas the image is also A dash B dash, it is also erect. It is not upside down. The image is not upside down. So how the object is, the image is also same. So that is why the first character says it is always virtual and erect. And you can see AB size, that is height of AB, is same as height of A dash B dash. So that is why the second character says the size of image is equal to the size of the object. So now we will move on to the third one, that is image is formed as far behind the mirror as the object in front of it. So what they are going to say is the object distance u is same as the image distance, that is u is always equal to v. So let me consider object height as h, image height as h dash. So we can say h is equal to h dash in the case of plane mirror. Similarly, u is equal to v in the case of plane mirror. So the last one is laterally inverted. Laterally inverted means, like if you stand in front of a plane mirror, if you raise right hand in the plane mirror, inside the mirror it will raise the other hand, that is left hand. So let me explain what is lateral inversion. So lateral inversion means that right side of the object appears left side of the image and left side of the object appears right side of the image. So this is what we call it as lateral inversion. So I have set you example, like if you raise a right hand, so in the image you will see the left hand will be raised. This is what we call it as lateral inversion. So characteristics of images I will explain you once again. So whatever the image formed in the case of plane mirror, so it is always virtual and erect. The size of object is always equal to the size of the image, and the object distance is always equal to the image distance, and the image formed is always laterally inverted. Laterally inverted means the right side of the object appears left side of the image. So there is one application, many applications are there. So here I am mentioning one application. So that is application of lateral inversion. The word ambulance is written as like this, okay, so that it can be read correctly in the rear view mirror of vehicles going in front of it. So this is the application of lateral inversion. So you might have seen in the ambulance it will be written ulta, like inverted, like lateral inversion letters will be written, so that you can easily see from the vehicle mirrors, so that you can give them a way. So this is the application of lateral inversion in the case of mirror. So next we will be moving on to the spherical mirrors. So here you got to know image formation in the case of plane mirror. So characteristics of image formed in the plane mirror is always virtual erect. Height of the object is same as height of the image. Object distance is always equal to the image distance, and the image formed is laterally inverted. So now we will move on to the spherical mirrors, that is the cut mirrors. If a spherical mirror is cut into two parts, like depending on the polished surface, we will get convex mirror as well as concave mirror. Let us see what are the kinds of mirror. So spherical mirrors whose reflecting surface is curved. You can see the curves, two curves are there. One is concave mirror, that is reflecting surface. Another one is concave mirror, that is the reflecting surface. So how we will differentiate concave mirror as well as convex mirror. Okay, so now you can see, okay, concave mirror as well as convex mirror. So first one is convex mirror. So in convex mirror, the reflecting surface is curved outwards. So you can see the reflecting surface, this reflecting surface is curved outwards. Okay, the other surface is polished, and this mirror is called as diverging mirror. Why it is called as diverging mirror? Because it will divert the rays of the light. So now concave mirror, so reflecting surface is curved inwards. You can see from the figure, the reflecting surface is curved inwards and the other surface is polished. So concave mirror is called as converging mirror because it converges the rays of light once it falls on it. So you know the difference between convex mirror and concave mirror. So let me explain it once again. In the case of convex mirror, the reflecting surface is curved outwards and polished inwards, whereas in the concave mirror, the reflecting surface is curved inwards and polished outwards. And convex mirror is called as diverging mirror because it will diverge the rays, incoming rays. Okay, whereas concave mirror is called as converging mirror because it will converge the rays to a specific point. Okay, let us understand the terminologies associated with the mirrors. So first one is principal axis. So you can see from the figure, P is the pole of the mirror, capital F is the focus of the mirror, and C is the center of curvature. The distance between the pole and the center of curvature, that is R. R is the radius of curvature, and you can see Mn. Mn is the aperture. Okay, and you can see principal axis also. So let us understand what are these terminologies. Okay, first one is principal axis. So the line joining the pole and center of curvature, the line joining the pole and center of curvature. You can see from the figure, C is the center of curvature and P is the pole. So the line joining, there is a line, that line joining the center of curvature and pole of the mirror, we call it as principal axis. Okay, next, what is pole? Pole is the center of spherical mirror. You can see this mirror, so cut mirror, that is Mn. So in that, this P is the center of the spherical mirror. So the pole is the center of the spherical mirror. Next is aperture. I already said Mn is the aperture. So what is aperture? It is the effective diameter of the spherical mirror. The effective diameter of the spherical mirror, we call it as Mn. So in this chapter we will be discussing with the small apertures. We will not consider the diameter wholly. So we will consider only the small apertures. So what is aperture? Mainly it is the effective diameter of a spherical mirror. Next concept is the center of curvature. So the center of a hollow glass sphere of which the mirror was a part. Actually this mirror is made with a hollow sphere. Okay, so hollow sphere is cut into 4 parts, 4 or 5 parts. Okay, so this cut parts, depending on the polished, like if we polish it outwards, we call it as concave mirror. If we polish it inwards, we call it as convex mirror. So depending on the polished surface, we call it as convex and concave mirror. So as this is a cut part of the sphere, so here you can see C as the center of curvature, the center of the hollow glass sphere of which the mirror was a part. So this is what we call it as center of curvature. So center of curvature is the part of the sphere, but it is not the part of the mirror because it is the part of sphere. Okay, next is radius of curvature. So the distance between the center of curvature and pole of the mirror, we call it as radius of curvature. Next point is the focus, or you can call it as principal focus. The point on the principal axis, see, you can see this is a point on the principal axis. It is represented by capital F. So the point on the principal axis where all the light rays actually meet or appear to meet after reflection. So I will repeat it once again. The point on the principal axis where all the parallel light rays actually meet or appear to meet after reflection, we call it as focus. Or you can say in other words, the incident rays after reflection from the concave mirror, they will converge to meet at one specific point on the principal axis. This point on the principal axis, we call it as focus. Or you can simply say the point on the principal axis where all the light rays actually meet or appear to meet. If they actually meet, you can say it as real image. If they appear to meet, you can say it as virtual image. So you will have both real focus as well as virtual focus. They will actually meet in the case of concave mirror and they appear to meet in the case of convex mirror. You will understand when I explain the image formation in the case of both the spherical mirrors. So just now know what is focus. Okay, next is focal length. So focal length, see from the figure, small f, the distance between the pole and the focus. The distance between the pole and the focus, we call it as focal length. It is represented by letter small f. So these are the terminologies associated with the spherical mirrors. Let me repeat it once again. So first I explained principal axis. It is the line joining the pole and the center of curvature. Next one is pole, the center of spherical mirror. Next one is aperture. It is the effective diameter of the spherical mirror. Next is center of curvature. It is the center of the halosphere, but it is not the part of the mirror. And radius of curvature, the distance between the pole and the center of curvature. And focus, it is the point on the principal axis where all the parallel light rays actually meet or appear to meet after reflection. So next is the focal length, that is the distance between the pole and the focus. Hope you guys understood all the concepts of or all the terminologies associated with the mirror. Next, there is one relation between the focal length and the radius of curvature. So this relation will be derived in the higher classes or in the foundation classes. So for now time being, so let us understand it as f is equal to r by 2. That is, from the figure you can see that f, the distance between the pole and the focus, is focal length. That is, small f is nothing but twice the radius of curvature. That is, f is equal to 2 times r. So from that we can say that f is equal to r by 2. Sorry, I said f is equal to 2 times r. It is not that. The total radius will be equal to the 2f. Okay, so you can see from this. So this is 1f. The other also, if you take it as f, the total 2f will be equal to the radius of curvature. So that r is equal to 2f. So as r is equal to 2f, so what will happen? F is equal to r divided by 2, where f is the focal length, r is the radius of curvature. So this we will be using in some problems. So some problems they will give radius of curvature, they will ask you to find out the focal length. So in that case you can see, you can use this formula to find out. Next concept, rules for making diagrams by concave mirror. So this is very important. So once you understand this, you can solve any kind of problems based on the image formation. So these are just rules. So for the image formation, so understand these rules, the image formation will become very easy. Okay, so first rule we will go. A light ray parallel to the principal axis. So you know principal axis, that is the line joining the center of curvature and pole. So this the line which is passing through the pole, we call it as principal axis. Okay, a ray parallel to the principal axis, that means you can see one ray above the principal axis is falling parallel to the principal axis. A ray parallel to the principal axis will pass through the principal focus after reflection. So if you send any ray passing parallel to the principal axis after reflection, it always passes through principal focus. So this is the first rule. First rule is, if you send any ray passing parallel to the principal axis, if you send any ray passing parallel to the principal axis, after reflection it always passes through principal focus. Okay, so second, a ray passing through principal focus of a concave mirror. So you can see here, So they are sending a ray passing through the focus or passing through the principal focus. After reflection it will go parallel to the principal axis. So if you send a ray passing through principal focus, after reflection it always go parallel to the principal axis. This is the second rule. And third rule, a ray of light passing through the center of curvature of a concave mirror reflects back along the same path. So here in the figure they have mentioned it as wrong, like they are passing the ray through the focus, but actually that F should be C, that is center of curvature. If you send any ray passing through center of curvature, after reflection the light ray will reflect back along the same path. Okay, because at the point of incidence, when you send a ray up through center of curvature, the ray will fall normally. That is this reflection, loss of reflection, the incident ray will be always equal to reflected ray, right? That is, if the angle of incidence is 30 degree, angle of reflection incidence is 30 degree, angle of reflection also will be 30 degree. So if you send a ray like exactly perpendicular to the normal, like if you send a ray normally, like angle of incidence will be 90, angle of reflection also will be 90. So here when you send a ray passing through center of curvature, so what happens, the point where it falls is normal. So because of that normal point, what happens, the light ray will reflect back in the same incident path. Okay, so next, fourth one is a ray of light incident obliquely to the principal axis of a concave mirror is reflected obliquely, making equal angle. So if you send a ray passing through pole of the mirror, after reflection it will reflect from the pole of the mirror. Obliquely means you are sending a ray through pole of the mirror. So this is the fourth point. A ray incident obliquely to the principal axis of a concave mirror is reflected obliquely, making equal angle. That means it is following laws of reflection, that is angle of incidence is equal to angle of reflection. So let us discuss once again. So first rule is, if you send a ray passing parallel to the principal axis, if the incident ray is passing parallel to the principal axis, after reflection it always passes through focus. So the second rule is, if you send a ray passing through focus, after reflection it will emerge parallel to the principal axis. Third one, if you send a ray through center of curvature, so after reflection it follows the same path. So fourth one, if you send a ray obliquely, the ray will reflect obliquely, that is making equal angle, that is angle of incidence is equal to angle of reflection. So these are the rules you need to understand, so before understanding the image formation. So let us move on to the image formation, how the image will be formed. So where exactly the image will form. Okay, first one, we will consider object at infinity. When the object is at infinity, what happens, where the image will exactly fall. So in the case of plane mirror, we did not have much, like wherever the object stands, image also stands at the same distance from the mirror. So height of the object is equal to height of the image. But in the case of spherical mirrors, it is not the same. So at every point, at every position, the image nature will change. So that is why we will discuss what exactly happened here. So first one, we will take the object at infinity. When the object is at infinity, you can see two rays falling on the mirror. So after reflection, they are meeting at one point, that is, from the figure you can see that B dash. Okay, B dash is the point where the image is formed. Okay, so here from the figure I can say that the position of the image is A dash, that is B dash, and the rays coming from the infinite point are meeting at the point B dash. So you can see the object is upside, whereas the image is upside down, that is object is erect whereas the image is real. If it is real, it is always inverted. Why I am calling it as real? Because the rays after reflection are actually meeting at one point, so I am calling it as real, and you can see the image is inverted. So in the case of object placed at infinite point, so where you will get the image, what is the nature of the image, what is the size of the image. So here they have given the position of the object, that is position of the object wherever it is, that is infinity. When we place the object at infinity, image will fall exactly at the focus, and when the image is formed at the focus, it is always real, it is always inverted, and size is highly diminished. You will see a point sized image. Okay, so for this, when the object is at infinity, you can see from the textbook image, this image is actually bit wrong. You can see the textbook image. So that image, when you place the object at infinity, so after reflection they will meet at a point called focus. So it is very point, like image is of point sized, and it is highly diminished in the sense it is too small. Okay, so nature is real and inverted. Okay, next is when the object is placed behind C, that is behind center of curvature. So when the object is placed behind the center of curvature, so you can take any two rays. So first ray, one ray is passing parallel to the principal axis. After reflection, you have already know it will pass through focus, and one more ray you take, they have taken it as through center of curvature. So if you send a ray through center of curvature, after reflection it follows the same path. So you can see the reflected ray from the parallel ray, and you can see the reflected ray from the which is passing through the center of curvature. They are meeting at one point, that is a dash b dash. You can see from the figure, ab is the object height, a dash b dash is the image height, and ab is the object which is erect, and a dash b dash is the image which is real. So real image is always inverted. Okay, so what is the position of the image? See the position of the image, it is formed between center of curvature and focus. So see the image, so image position is between focus and center of curvature. Nature, I already said its nature, it is real and inverted. Size, you can see the size, you can compare the size of the object with respect to image. So image size, you can clearly say it is diminished. So this is the second. So we will move on to the third. So that is third one is, so when the object is placed exactly at the center of curvature. So when the object is placed exactly at the center of curvature, so you can see AB is the object, one ray they have sent through, one ray is going parallel to the principal axis, and one ray they are sending it through the focus. So after reflection they are meeting at a point a dash b dash. You can see clearly from the figure. Okay, that is, you can see that AB, the height AB is equal to height a dash b dash, and the distance from the object to the mirror is equal to distance from the object to the image. That is, object distance is u, image distance is v. So object distance is equal to image distance. So from this you can say that if the position of the object is placed at center of curvature, the image is also formed at center of curvature, and the nature of the image is always real and inverted, and the size of the image is same as size of the object. So when you place the object at center of curvature, remember you will get the image at center of curvature, and the image size is same as the object size. Okay, so this center of curvature we can say it as 2f, or radius of curvature. I already said radius of curvature is nothing but 2 times the focal length. Okay, so next one is when the object is placed between focus and center of curvature. So when the object is placed between focus and center of curvature, you can see one ray is passing parallel to the principal axis. Of course, if a ray passing parallel to the principal axis, after reflection it will pass through focus, and one more ray they have taken through center of curvature. When these two rays after reflection they actually meet at one point, so that kind of image we call it as a real image. That is, in this diagram they are meeting at point A dash B dash. So if you place the object between center of curvature and focus, you will get the image behind, that is C, center of curvature. So from the diagram I can conclude that if you place the object between center of curvature and focus, your image will be always formed behind center of curvature, and nature you can see the object is erect, the image is real and inverted, and size you can see the object size and the image size. Object size is small compared to the image, so size of the image is enlarged. Understood? So next, when the object is placed at focus. So what happens when the object is placed at focus? You can see, you can take two rays. Okay, for the formation of image you need minimum of two rays. So one ray they are taking like passing parallel to the principal axis. If a ray passing parallel to the principal axis, you know after reflection it will pass through focus, and if you take a ray passing through center of curvature, of course it will reflect back in the same path. So from the figure the two rays are parallel, that is the two reflected rays you can see they are parallel. So if the reflected rays are parallel, so we will take they never meet actually, but we will consider they may meet at one point, that is at infinity. So the image is formed in this case is at infinity. So nature of the image as it is going downwards, so we will take it as real and inverted. So size you cannot like imagine, so it is very large. Okay, so size is highly enlarged. So when you place the object at focus, the position of the image will be at infinity, the nature of the image is real and inverted, and the size is highly enlarged. So this is the fifth. So next is we will place the object between focus and pole. So this is the last one. So when we place the object between pole and focus, so you can see from the diagram, so object is placed between, that is AB is placed between F and P. F is the focus and P is the pole. So one ray they have taken passing parallel to the principal axis. If a ray passing parallel to the principal axis, after reflection it will pass through focus. Okay, so one more ray they have taken through center of curvature. Of course you know it will reflect back in the same path, but as these two rays, so the reflected rays they never meet at a one point. So what we have to do is we have to draw them backwards. The reflected ray should be drawn backwards. So those reflected rays when drawn backwards meet at one point behind the mirror. So that means the rays are appearing to meet at one point. So I already said you, if the rays are appearing to meet, that kind of image we call it as virtual image. Also virtual image is always erect. You can see AB is upside, whereas A dash B dash is the image that is also upside. So this kind of image we call it as erect, and the rays are appearing to meet, we call it as virtual. So virtual image is always erect, and real image is always inverted. So let us discuss the image position, nature and size. Okay, so when the object is placed between focus and pole, the position of the image, as you can see from the diagram, it is always behind the mirror, and nature virtual erect, and see the size of the object and size of the image, it is enlarged. Okay, let us discuss once again these concepts. So first is when the object is placed at infinity, so you will get the image at focus, the image nature is real and inverted, and its size is highly diminished. So when the object is placed behind center of curvature, so you will get the image between focus and center of curvature, nature is real and inverted, and size is diminished. So next, when the object is at center of curvature, so the image position is also at center of curvature, it is real and inverted, and size of object is same as that of the size of the image. Next one, when you place the object between focus and center of curvature, so position of the image will be beyond C, and nature is real and inverted, and it is enlarged. When you place the object at focus, so position of the image will be at infinity, it is real and inverted, and it is highly enlarged. When you place the object between pole and focus, you will get the image behind the mirror, and it is virtual erect and size is enlarged. So these are the six, I think, formation of image in the case of concave mirror. Okay, so hope you have understood the ray diagrams for the image formed in the case of concave mirror. So let us discuss uses of concave mirror. So where we will be using the concave mirrors. Okay, so concave mirror is used in torch or searchlights and vehicle headlights to get powerful parallel beam of light. Okay, so that is the bulb is placed at the one point and it will reflect the light rays in specific direction. So that is why concave mirror is used in torches, searchlights and vehicle headlights. It is the mirror which is very useful in torches also, torches everywhere like lights, vehicle headlights. So next is concave mirrors are used by dentists to see large image of teeth of patients. So in order to see the large image of the patient, like patient's teeth, so where you will get the large image, and the image should be virtual erect. Okay, that is as it is. So when you place the object between focus and pole, okay, you will be getting large enlarged image, like that is enlarged image which is virtual and erect. So in case of concave mirror, you if you place the teeth like between focus and pole, you will get the image virtual erect and enlarged. That is, you can see clearly see the teeth. So that is why dentists will use this in their uh, operations or whatever. Okay, next, concave mirror is used as shaving mirrors. So why they will use it as shaving mirrors? Because when you place your face between focus and pole, you will get your face enlarged. You can see clearly, you can shave clearly without any problem. So that is why concave mirror is used as shaving mirrors. So large concave mirrors are used to concentrate sunlight to produce heat in solar furnace. So solar furnace you have seen, so it is same as like a curved surface. So large, it will be very large in order to focus the light at one point. So they will focus the light at one point to produce enormous heat. Okay, so these are the four uses of concave mirror. One is it is used in torches, searchlights or vehicle headlights. Second one, it is used by dentists to see the large image of the teeth. Third one, it is used in shaving mirrors to see the large image of face. And fourth one, it is used in solar furnace to produce large amount of heat. Okay, so next we will be discussing about rules for the formation of image by convex mirror. So previously I have discussed about concave mirrors. Now I will discuss about convex mirror. So here there are only two rules, I think. Let's see. First one is a ray of light parallel to the principal axis. That is, if you send a ray passing parallel to the principal axis, after reflection it will diverge. As you can see, it is diverging because convex mirror is a diverging mirror. It will diverge the rays falling on it. So when this divergent ray produced backwards, that means if you draw this divergent ray, like if you draw this reflected ray from the mirror backwards, it always meets at focus. So remember the first rule for the convex mirror: if you send a ray passing parallel to the principal axis, in the case of convex mirror, after reflection the ray will diverge. If this divergent ray produced backwards, it will always meet at principal focus. So this is the first rule. The second rule: a ray which is directed towards the focus of convex mirror will emerge parallel to the principal axis. That means if you send a ray appearing to pass through focus, okay, so if you send a ray appearing to pass through focus, after reflection it will go parallel to the principal axis. So these are the two rules. And the third one, that is a ray directed towards the center of curvature. If you send a ray appearing to pass through center of curvature, after reflection it will reflect back along the same. So same, similar to the concave mirror, here also same, but the image is different. There we will use concave mirror, here we will use convex mirror. Next, the ray incident obliquely to the principal axis, same here also, there also. Okay, there also if you send a ray obliquely it will reflect back obliquely, here also if you send a ray obliquely it will reflect back obliquely. So let us review once again. So first one, if you send a ray passing parallel to the principal axis, after reflection the ray will diverge. If you draw the ray, the divergent ray backwards, or if you produce the divergent ray backwards, it will always meet at focus. The second one, if you send a ray appearing to pass through focus, after reflection it will go parallel to the, or it will emerge parallel to the principal axis. The third one, if you send a ray passing through, appearing to pass through center of curvature, after reflection it will follow the same path. The fourth one is, if you send a ray obliquely, after reflection it goes obliquely. So these are the rules in the case of convex mirror. So let us see the image formation in the case of convex mirror. So in the case of concave mirror, we have taken the object firstly at infinity, next behind C, next at C, next center of curvature and focus, next at focus, next between focus and pole. Here also we will do the same thing. So first, when we place the object at infinity, let's see where the image will form. So first one is, when the object is placed at infinity, so see, the rays are coming from infinite point, so after reflection they are diverging back. Okay, so when you draw these divergent rays backwards, so from the first rule you can say they always meet at focus. So here the rays are appearing to meet, you can see the rays are appearing to meet, these dotted lines represents the rays are appearing to meet. If the rays are appearing to meet, you already know it is always virtual. If it is virtual, it is always erect. Okay, so the image formed will be at the focus, and nature of image is virtual and erect, and size is point sized. Okay, so this is in the case of convex mirror. So first one, so now we will place the object anywhere between pole and infinity. So if you place the object anywhere between pole and infinity, where our image will be. So first, AB is the object, so take one ray, that is one ray passing parallel to the principal axis. After reflection it is diverging back. Okay, so take one more ray which is appearing to pass through center of curvature. So you can see the dotted lines in the diagram. So first ray, that is first ray which is passing parallel to the principal axis, it will diverge. If you draw this divergent ray backward, it will pass through focus. And the second ray, you are passing it like appearing to pass through center of curvature, and these two rays are meeting at one point, that is A dash B dash. That is where you will get the image. You can see the difference between AB and A dash B dash. Okay, AB is also upright, A dash B dash is also upright, that means image is erect. And see the size, AB is like large, A dash B dash is small, so therefore the size is diminished. Okay, these are the two ray diagrams of image formed by convex mirror. So first we will place the object at infinity, we will be getting the image at position F, and nature is virtual erect, size is point sized. Okay, next we will place the object anywhere between pole and infinity, so we will be getting the image between pole and focus, the right side of the mirror, and its nature is always virtual erect, and the size is diminished. So these are the ray diagrams associated with concave mirror. So next is uses of convex mirror. So convex mirrors are used as rear view mirrors in vehicles. Why why convex mirrors are used as real view mirrors in vehicles. So you can see from these two like image, first one is point size, second one is diminished. So because it will always give you virtual erect, see in the first case also it is giving nature as virtual erect, in the second case also it is giving nature as virtual erect. Okay, in the two cases it is giving virtual erect. So you can clearly say plane mirror also give virtual erect as well as convex mirror also give virtual erect image. And here in the case of plane mirror, object size depends on the distance. Okay, and also object size is always equal to image size. But in the case of convex mirror, object size differ from image size. So image size you will always get it as diminished or point sized, you will never get enlarged image in the case of convex mirror. So that is the reason mainly we use the convex mirror in the rear view mirrors, so that you can see the huge traffic behind the behind your vehicle. Okay, so they are also why they have given the reason why convex mirrors are used as rear view mirror, because they always give an erect though diminished image, and they have a wider field of view, they are curved outwards, so they will give wider field. Like you can see 1 kilometer traffic from the mirror and 1 kilometer traffic also with the persons appearing as diminished. So whoever the person standing behind your car or vehicle, they will appear very small in the mirror. So that is the reason we will be using convex mirror in the case of rear view mirrors. So let's see the next application of convex mirror. Convex mirror are used at blind turns. So we usually convex mirror are used in traffic signals, like wherever the blind turns will be there, so you can see convex mirror will be installed there, so to avoid accidents or to avoid merging of traffics. Okay, so next is it is used in shops as a security mirror. You can see in several shops, so they will have convex mirror to uh, have security. Okay, so these are the three applications of convex mirror. So first application of convex mirror is convex mirror are used as rear view mirrors in vehicles because they always give an erect through though diminished image. They have a wider field of view so that you can see the large traffic behind you. And the second one is convex mirrors are used at blind turns on the points of merging traffics, or to facilitate vision of both side traffic. You can see, like you can have enlarged view of the traffic, and it is used in shops as a security mirror. So these are the today's topics. I will stop at this point. Hope you have understood. Once again go through the video if you want to clearly understand. Okay, have a good day.